Okay, now we will turn to modeling and numerical approaches for air quality assessment. And we have Mr. Bertrand Bessagnet from the French National Center for Scientific Research, who will speak about CHIMERE model and innovative approaches, numerical approaches. So Dr. Bertrand is a research director at CNRS with over 2 decades of leadership roles in air quality management, modeling, and environmental research across Europe and Asia, including previous positions at ICIMOD, the European Commission's Joint Research Center, and major contributions to the CHIMERE model and France's National Air Quality Forecasting System. So please welcome Mr. Bertrand Bessagnet.
Thank you very much for the introduction. And good morning, everyone. So now we will talk about air quality modeling. So air quality is very important. It's one of the pillars of the air quality monitoring and management strategy with observation and emissions. And in my research center, we develop a model called CHIMERE. Okay, this model can be used everywhere in the world. So you can apply, open a window everywhere in the world, and we can work at the resolution of 1 kilometer to 1 degree resolution, roughly. So recently we did some simulation over Bhutan at 1 kilometer resolution. And here you can see, for instance, the impact of forest fires up to the glaciers. You can see the mountain close to the border with China. We have also some tests currently in Europe at 1 kilometer resolution of a big domain. So this is quite challenging to do this kind of high resolution simulation. First, because you need an emission inventory at this resolution. And this is a major problem for us. So far we use at the global scale what we call a global emission inventory. One of the most famous is EDGAR at more or less 10 kilometer resolution. So we did a specific work to downscale this emission at 1 kilometer resolution. And as you can see for the west part of Bhutan, there is no laser, okay. On the west part of Bhutan, you can see the improvement of the emission. You can see the road, for instance, at the bottom, better in the valley of Bhutan. But probably we need, we use satellite data usually to spatialize these emissions, but probably we could do more with ground-based data like mobility data. I'm sure that Google has all the data we need to do that. So probably we could have a good collaboration with this kind of company to do some proxy relevant for the community, modeling community. And also for exposure could be interesting. Also, we have a collaboration with the Joint Research Center at the European Commission to apply a model that is called SHERPA. It's a simplification of an air quality model. It's a statistical approach. So instead of taking 1 day to 1 week to simulate the air quality for on an annual basis, you can do the simulation in 1 minute. So for that, there is some developments, but we have a project now in Southeast Asia to have this model for the region here. So you can access, I could give you later if you come back to me, you can access this model and you will see for Europe how it works. It's free, you just have to register. And you just have to select some regions, the pollutant you want to reduce, the sector you want to reduce, and you have the impact directly, and you can calculate the cost and the benefits also of this, of your emission reduction strategy. So there is an offline version and an online version that is accessible by the website. Now everything, AI is in everything, all projects, I would say, and also in models. So this is probably the next challenge. We have to create new models. So our strategy now is to use air quality models to train neural network architectures, and then to develop some new models able to tackle both the high resolution or low resolution, and to have some simulation in only 1 minute. So the goal is to have an air quality forecast, for instance, in 1 or 2 minutes, and evaluate also the strategies, emission reduction strategy very quickly. So I stop here. And tomorrow I have an extended presentation during the CRES and partner session. Thank you.